Welcome back. In our last video, we talked about how machine learn. Today, we are zooming in on one of the most fundamental tools in a data scientist toolbox, regression. The word regression sounds complicated, but it is actually very simple. In the world of machine learning, regression just meaning predicting a number. If you are trying to guess whether an email is a spam or not spam, that is classification. But if you are trying to guess how much a house will sell for or what the temperature will be tomorrow, that is regression. Today we are going to look at the two most popular types, linear regression, the straight line, and polynomial regression, the curved line. By the end of this video, you will understand not just how they work, but why we choose one over the other. Let's start with the simplest one, linear regression. Imagine you are a real estate agent. You want to predict the price of a house. You have data from the past and you notice a simple pattern. The bigger the house, the higher the price. If you plotted this on a graph with house size on the bottom and price on the side, the dots would roughly go up in a diagonal direction. Linear regression is basically the computer taking a ruler and trying to draw the best possible straight line through these dots. It tries to draw a line where the distance between the line and every single dot is as small as possible. This line helps us predict the future. If a new house comes on the market, we just look at its size, go up to our red line and see what the price matches. The math, you might remember this from high school. Y equal to mx plus c. Y is the price, what we want to predict. X is the size, the data we have. M is the slope. It tells us how steep the price rise is. If M is high, a small increase in size adds a lot of money to the price. C is the intercept. It's the starting point. Even if your house size was 0, which is impossible. But stick with me. There might be a base cost just for the land. So linear regression is just the computer searching for the perfect slope M and intercept C to fit your data. Linear regression is great where the relationship is simple and constant. If one thing goes up and other goes down at a steady rate. The problem, underfitting. But life isn't always a straight line. What if we try to predict something more complex? Let's say we want to predict how effective a medicine is based on the dosage. If you take 0 mg, it doesn't work. If you take 10 mg, it works great. But if you take 100 mg, it might be toxic and make you sicker. If you plot this on a graph, the dots would be up and then come crashing down. It's look like a frown or an upside down U. Now imagine trying to draw a straight line through the curve with a ruler. You can't it. If you draw a line going up, you miss the drop at the end. If you draw a flat line through the middle, you are missing everything. This is called underfitting. The model is too simple. It's like trying to cut a stick with a spoon. The tool just isn't right for the job. This is where polynomial regression comes in to save the day. Polynomial regression, the curve. If linear regression is a rigid steel ruler, polynomial regression is a flexible piece of wire. You can bend it to fit the shape of your data. Instead of just using x, straight line, we add powers to the equation like x square or x cube. X square gives us a curve, a parabola, perfect for the medicine example. X cube allows the line to go up, then down, then up again. The computer is now calculating the curve that follows through the data point much more naturally. Real world example. Think about the spread of a virus. It starts slow, then shoots up exponentially, and then even actually flattens out. A straight line can't predict that. A polynomial curve can. The danger zone, overfitting. However, there is a catch. You might think, why don't we just make the wire super flexible and hit every single dot perfectly? If you make the equation too complex like x to the power 20, the line will go crazy. It will wiggle and squiggle just to touch every single random piece of noise in your data. This is called overfitting. The model has memorized the training data so well that it fails to predict anything new. It's like a student who memorized the answer to the practice test but fails the real exam because they didn't learn the concepts. Summary and comparison. So let's summarize the difference. Linear regression, shape a straight line, used when the data shows a simple steady trend. Example, height as weight, hour studied as exam score. Fast, simple and easy easy to explain to your boss, can't handle complex patterns. Polynomial regression, shape a curve used when the data fluctuates or has a non-linear pattern. Example, biology, epidemics, stock market trends. Much more accurate for complex real-world data. Easy to overcomplicate, overfit if you aren't careful. Understanding regression is the first major step in becoming a data scientist. Whether you are drawing a straight line or a complex curve, the goal is always the same, finding the hidden signal in the noise. In the next video, we will look at a classification, how machines decide between yes and no. If you found this helpful, hit that subscribe button so you won't miss the next lesson, and tell me in the comments, can you think of a real life example that follows a curve instead of a straight line? Thanks for watching and keep learning.